Hello, this is Liz here from Maths for Granted. Today we are looking at GCSE Further Maths and we're going to look at something called the binomial expansion that you definitely will not have met at GCSE, and you will love this. It's going to enable you to be able to expand a bracket to the power of n, where n could be 2, 3, 4, 5, 6, 7, etc. So it's called the binomial expansion because you only have two terms in your bracket. And personally, if it was just squared or cubed, I would probably just expand in the normal way, because this method using Pascal's triangle takes a little bit longer. So I would definitely do it for, to the power of 4 and beyond. Okay, so let's have a look how we expand lots of brackets all the same times together. So you'll be able to do things like 1 add x to the power of 5. You'll be able to do 3 take away 2x to the power of 4. You'll be able to do 2x take away 7 to the power of 5, that sort of thing. Okay, so let's have a look how we do it. We're just going to look at the coefficients first. Remember, the coefficients are the numbers that sit in front of your terms. So let's have a look at the coefficients. Well, let's start with one that you should already be able to do, a plus b all squared. And you could just use FOIL on that, couldn't you, or your grid method, and you get a squared add 2ab add b squared when you've neatened up the BA and the AB. And remember, all I'm interested in at the moment is I'm just looking at the coefficients really. So notice it goes 1, 2, 1 in that order. And notice my powers of A are going down, my powers of B are going up. So it's all about the order that you write these things, you'll soon see. So let's just look at the coefficients. So 1, 2, 1. Now we'll do triple brackets, a add b times a add b times a add b. So I would just do that in the normal way. Well, you already know a add b squared, which is a add b times a add b. So we've just done that. So we might as well now just times your a add b squared with a times all of those out, and then b times all of those out, and you'll get 6 terms, but those terms will simplify to 1a cubed add 3a squared b add 3ab squared add 1b cubed. Notice your powers of a are going down, notice your powers of b are going up, but more importantly at the moment we're looking at the coefficients 1, 3, 3, 1. Okay, let's have a look at a add b to the power of 4. Well, we know what a add b cubed looks like, so we could just times a add b cubed by another a add b, so something like that, and you're going to get a times all of that, which will be 4 terms, and then b times all of that, which will be another 4 terms. So you'll have 8 terms, but then you can simplify it to 1a to the 4 add 4a cubed b add 6a squared b squared add 4ab cubed add 1b to the 4. And again, notice your powers of a are going down. That's a to the 1. Think of that as a to the 0 there, even though you can't see it. And the same with the powers of b. Think of it here as b to the 0, even though you can't see it, which would be 1, wouldn't it? And then that's b to the 1, b to the 2, b to the 3, b to the 4. But again, just looking at the numbers, it's 1, 4, 6, 4, 1 in that particular order. So far we now have, when we're just squaring, we get coefficients 1, 2, 1. When we're cubing, we got 1, 3, 3, 1. When we're expanding to the power of 4, we got 1, 4, 6, 4, 1. Well, we could go backwards actually and look at a plus b to the power of 1. Well, that's just a plus b, isn't it? Which is a 1 and a 1 as a coefficient. And a plus b to the power of 0, everyone forgets to the power of 0 is 1, isn't it, and not 0. So I've got this nice shape appearing, and it's called Pascal's Triangle. It's named after the French mathematician Blaise Pascal, who first put it to good use. He was a mathematician round in the 1600s. And let's have a look at some patterns then. So hopefully you've noticed these ones coming down at the start and at the end of each row. So that's the first thing to spot. And more importantly is the fact to get the row underneath, I don't know if you can spot this, you can add the two numbers above it together. So 1 add 3 would make that 4. 1 add 2 would make that 3. 3 add 3 would make that 6. 3 add 1 would make that 4. I suppose you'd argue 1 add 0 here would make that 1. Okay, so you can actually quickly get the row underneath. First and last numbers are always 1. We've just said that, haven't we? So notice that the actual fourth row down, 1, 2, 3, 4, is a plus b cubed. But it's probably easy to remember it as if you want something cubed, you'll use the row that starts 1, 3. If you want a plus b to the power of 4, you'll use the row that starts 1, 4. Which is what we've just sort of said there. So if you wanted to do a plus b to the 10, you'll have to carry on a bit longer with your triangle, but you'll basically want the coefficients and the row that starts 1, 10. Okay, so let's have a look just at the coefficients. I'm not worried about actually expanding the brackets. I'm just looking at the coefficients. So we've done the first 6 rows already. So to get the next row down, I simply, remember it starts and ends on a 1, and then remember you just add the two numbers above it together. So 1 add 5 must be 6, 5 add 10 must be 15, etc. And hopefully you've noticed it is symmetrical. Yeah, from left to right. Okay, so obviously if you want to expand lots of brackets, we don't just want to worry about the coefficients, we want to know what the actual full expansion is. So let's have a look at a plus b to the power of 5. Well, first of all, let's get the coefficients. So we know it starts 1, 5. So we pick up that row in Pascal's triangle, 1, 5, 10, 10, 5, 1. You might want to be writing down Pascal's triangle, I don't know, the first 7, 8, 9 rows. Most people can learn the first few rows as well. Okay, so that's the first thing we do. And then the full expansion is, and we've partly talked about this, I take the first term and I raise it to the power of the bracket, a to the 5. And then each subsequent term, it then goes down by a power, a to the 5, a to the 4, a to the 3, a squared, a to the 1, but of course we just write a, and a to the 0, but you don't need to write that in. And you go up in increasing powers with the second term. So there's a b to the 0 there, but you don't need to write it. That's a b to the 1, but you can just put b squared, b cubed, b to the 4, b to the 5. Okay, so hopefully it's starting to make a bit of sense. And that's also important, I forgot to say that in each term your powers should add up to the power that's given in the question. So look, you've got 1 add 4 there would make the 5. Yeah, and you've got like an a to the 0, 0 add 5 there would make the 5. Okay, and we've talked about going down in one power but increasing in the other power. Okay, now it's all very well if it's just a plus b all the time, but of course in maths it's not always going to be a plus b. So let's have a look how we have to adapt what we've just learned if now we've got a 1 instead of an a and we've got a minus x instead of a b. So we start it off the same, we sort out the coefficients first, and then if you prefer you can sort out your a plus b to the 4 first, and then all you're doing is for every time you see an a you're going to replace that with a 1. And every time you see a b, you're going to replace it with minus x. Now put that in brackets so you don't get muddled up with that negative. You will see what I mean shortly. Okay, so I think on this PowerPoint it does it separate. So we've replaced all the a's with a 1. Hopefully you can see that. And then we're going to replace the b with minus x. Notice we've got brackets around it because I want you to be spotting, for example, minus x all squared will actually be positive. Minus x to the power 4 will be positive. Whereas this term here will be negative, this term here will be negative. Well, luckily when it's 1, we don't really have to do 1 to the 4, 1 cubed, 1 squared, 1 etc. because we know they're just 1. So all you're worrying about is doing 4 times minus x, 6 times minus x all squared, 4 times minus x all cubed, minus x to the 4. And it simplifies to that. And you will always get this alternating sign if you have a negative sign here, like we have at the start there. Yeah. Okay, let's have a look at one more. So I'm doing 1 plus 2x to the power of 5. So let's see what happens. We know what the coefficients are. It's the 1, 5, 10 row. And then let's remind ourselves if it was a plus b to the 5, that's what we had before, didn't we, from an earlier slide. Now, what we're about to do then, and I think it doesn't show you exactly what's happening here, but I'm about to replace the a with a 1. Okay, but if you replace the a with a 1, 1 to the 5, 1 to the 4, 1 cubed, 1 squared, 1, it's all going to be 1, isn't it? So I don't think in this example it shows you that, but what it goes straight on to showing you is the b is getting replaced with a 2x. So I haven't bothered showing all of the 1 to the 5, 1 to the 4, 1 to the 3. But notice, look, I've got 2x. And then look, it's so important to put brackets around this because so many students at A-level forget it's all of that squared. It's all of this cubed. And it's all of that to the power 4. So you'll soon see your numbers start to quickly get quite big. Okay, so then you work out what that is. 5 times 2, 10 times 4, 10 times 8, 5 times 16, 2 to the 5 is 32. Okay, so I think that's the last one. Hopefully that makes sense. And I know you can't see your powers of 1 going down there, but you can certainly see your powers of x increasing there, can't you? Okay, I think this PowerPoint was from Westcliff High School for Girls, so thank you to them. And hopefully that makes sense, and you will certainly be using it quite a lot at A-level as well. Thanks, bye.